Hi, my name is Ryan O'Hara, and today we will be talking about reliability in student assessment. So today's learning objectives, first we'll be talking about and understanding what factors influence test scores and how educators reduce these factors, define reliability, and discuss how it relates to student assessment, discuss the importance of reliability as relates to student assessment, understand the difference between reliability and validity and how they are related, as well as determine how we calculate the reliability of a student assessment tool. So let's first talk about what factors influence a test score. So the biggest thing that influences a test score is the actual test taker's knowledge and the skills that they possess, and specifically about what the test is actually asking and supposed to measure. The second things are scores can depend on the knowledge and the skills that the test is not supposed to measure. This is things such as reading and writing ability, using test time efficiently, how to guess on multiple choice questions, the test taker's concentration on the test day, if things outside of their work has really affected their mental capabilities that day, if it's the grader of the test, if it's a short answer test, so if it's one person versus multiple, which is why you'll notice that on a lot of bigger exams, there's more than one person who actually grades the essays and the test. And then the last thing is just luck of the draw. If you studied the right things that the test maker felt was important, and those are the questions that they ask, then you're going to do better because just luckily those you studied the right things and knew the right specific questions and how to answer those. So how can educators reduce chance factors? First is create a detailed specifications for the content and format of the test. Avoid reporting scores based on a few multiple choice questions. Adjust the scores to compensate for difficulty between tests. Create explicit scoring instructions. Train graders thoroughly. Test the graders on previously graded tests and see how they compare to see if they're within the right ballpark of the previous grader, and monitor the grader's performance. If they overall are just giving worse grades than others for the same testing and the same rubric, then that's something that you need to evaluate and look at. So let's talk about reliability. So reliability of a test score is the extent to which they are consistent across different occasions of testing, different editions of the test, or different rate scores on the test taker's responses. The terms associated with test reliability are the true score, the error measurement, the standard error measurement, the observed score, and there are multiple. There are a lot of things that go along with test reliability, and kind of the umbrella term is the reliability with these terms underneath it. Reliability is important because it ensures that the testing measurement is consistent and fair between students and classes, as well as between grades, etc. Reliability is consistency. Consistency is key. So it's really something very important to look at whenever you're developing a test. So a little bit about the difference between reliability versus validity. So reliability is how consistently test scores measure something, whereas validity is tells whether test scores are measuring the right things for a particular use of the test. Which is more important? Well, validity would be if you're measuring the wrong thing, it does not matter how well you're measuring it. So you can see below, this gives a great example. So if you have a low reliability, you've got kind of all these answers and these choices scattered throughout this dot. If you have a high reliability but a low validity, everything is right grouped together, which is great, meaning that it's consistent and you're getting all the same answers or the same response, but it's not the right one. And so what you're really looking for, that sweet spot, is the high reliability and high validity. There you're kind of right in the middle, you know that that's where you want to be. And that's something that you kind of, it's a balance between the two. But if you had to pick one, validity is the key. So true score versus error of measurement. So true score is the average of the scores the test taker would have had, averaging over a specified set of conditions. So the best thing to remember with this is the true score is the average. This may not be a true indication of the skills the test is intended to measure. Anything affecting consistency can affect a true score. This again, those luck of the draw things and things we talked about earlier in the presentation can affect the true score. The error measurement is the difference between the test taker's true score and the score the test taker actually got. So you would also call this the observed score, is the test taker's actual score. So it's kind of a little bit different between the error measurement and the observed score, but something kind of key to understand for terms associated with reliability. So observed score, test taker's actual score, the error measurement, the difference between the test taker's true score and the score the test taker actually got. The reliability coefficient and standard error measurement. So the reliability coefficient is the correlation between the test taker's score on two applications of testing processes. So here you're looking and getting a number that's an absolute number ranging from 0 to 1. 1 indicates a perfect consistency, which is kind of, obviously the key in what we're looking for, whereas 0 indicates complete lack of consistency. The standard error measurement is a number expressed in the same units are the score that it refers to. And the standard error measurement indicates consistency of the test taker's score, not the positions in the group, but the scores themselves, whereas 0 indicates a perfect consistency. So for the standard error measurement, or SEM, it's a standard deviation. This is where you kind of think of that bell curve that we do with a lot of grading, but 0 indicates a perfect consistency, so that would be the goal there, whereas 1 for the reliability coefficient is what we're looking at and what we would like to get to. So calculating reliability. So when trying to calculate reliability, there are a multitude of ways to view the reliability. The reliability coefficient and standard error measurement are related, thus you can calculate these using the formula below. So reliability coefficient, 1 minus, and then you see those that formula there squared. And so when I was looking this up and kind of reviewing, there's a ton of different formulas for this. This seemed to be the most encompassing, kind of get you that bell curve and allowing you to find that reliability coefficient as well as the SEM, which are big ones. So test length and alternate forms reliability. Overall, the more questions, the more reliable test, simply because there are more data points to use in the calculation. But there is kind of a fine balance, which you'll see in the next few slides as to how many before it gets to not too much, but just nothing that really changes things a lot. Yet how many is enough before it gets to too much? So in this example, the reliability coefficient and the SEM for test are from 15 to 200 questions. So as you'll see below, 15 questions, the reliability coefficient's about middle of the road, 0.57, whereas if you get to 200, it's 0.95. But if you look, only 100 questions, you get 0.9, which is pretty good. So you're only getting a 0.05 change over 100 questions. As well as the same for the SCM. So you're at 7.7 for 15 questions, whereas at 200 you're at 2.1, at 100 about 3, 150 about 2.4. So it's interesting when I was reviewing this, because the PANCE obviously is about 300 questions, 240 graded, and 60 of them, field test questions. So it kind of made more sense as to how the exam creators chose that specific length. So this is just a chart that kind of shows all of that. So the reliability coefficient to the number of questions on the left, as you can see, it starts to flatten out about that 150 range, as well as the SEM of percent correct scores to the number of questions. Again, you start to see it flatten out about 150 or so. So overall reliability, it's more than a single definition, something very important to know. There's a lot that goes into making a test reliable. As an assessment administrator, you need to determine what you are actually trying to achieve, determine your reliability factor, and use this to ensure reliability and hopefully validity too along the way. And here are my references.